I'm going to take the liberty a little bit, instead of doing a regurgitation of the session, but really kind of give maybe a perspective, essentially. Our session kind of overlapped with lots of the other sessions, and so first in homage to Ranga and Jan Pizik, who like to have art and figures, I kind of have this idea of really our big picture. This whole community, the reason we're here in some respects is we really want to understand fluxes of the biosphere everywhere, all the time, essentially. And the reality is there's no one sensor that does it, that works at all scales at all times. And so we really have to bring together modelers, flux networks, and remote sensing together to really come up with an integrated product. And that's why we think meetings like this and everyone coming together to talk and learn from each other are really, really critical. Now, in the last year or so, I've kind of given a couple of talks on this topic, and I've seen more talks on this topic here. Despite having more and more data, I think we're learning less about the biosphere and global photosynthesis, and we've gone backwards. Recently, I did this histogram of global GPP from the models, and we're getting numbers like 140 to 150 petagrams. If this was true, we'd have no CO2 problem. We'd solve it. So obviously, these numbers are way off. And so, why? Well, it gets back to the types of models we're using. Obviously, we have a hierarchy of models. There's simple models. There's very, very complicated models. I understand and appreciate at large scales, big models have to use simple models. But we can't forget the issue of Jensen's inequality. We're trying to integrate a lot of non-linear processes. What does this mean? Well, the average of the mean is different than the mean of the average, essentially. We have the average correctly. And so we have to think about doing this well. Now, when you look at the comparisons from a lot of these global models with real data, they're way off. Schaefer says, none of these models match estimated GPP within the range of uncertainty. Well, my criticism is most of these models tend to ignore sun-shade effects and are essentially just big leaf models. So it gets back to this issue of we got to get dirty. We got to get out in the field. You got to touch the system you study. You really have to collect data to get us some insights of what's going on. And from this, we also can't forget literature. We have to go back to the basics. Dovitt back in the 60s and Duncan back in the 60s created some of the earliest models. In fact, Justice mentioned about agrostars. A lot of the best ideas were from agriculture, and then we forget about them, essentially. These guys back in those 60s created these wonderful integrated models that can combine sun-shade fractions. And I also had Monsi and Seiki from Japan also back in the 50s, essentially. The other thing we find when we go out in the field is that the real world is clumped. You see pictures like this. Leaves are clumped. So the basic idea of using turbid median models can be challenged. It may not be universal all the time. So I was really excited at this meeting because there's more and more people coming together to try to assess clumping. We're still at the very naive day. We're at the pioneer stage with clumping. We just are collecting data. We need to understand what is clumping, how does it vary, how is it as a functional trait. We need to pull together the data and try to upscale it. Jing Chen, for example, is one group that's trying to produce a global map. We still need to validate that map and maybe come up with alternatives for that map. But why is clumping important? Well, totally independent tests of upscaling models find that if we just use a turbid median model that assumes the leaves are randomly distributed, has terrible comparison between CO2 fluxes and what we measured on here. When we actually had independent measurements of clumping and put them in the models, they match. So this kind of gets back to my point, is that the next generation of DGVMs and larger scale models, again, need to have better radiative transfer modeling. Because with the radiative transfer modeling, we can produce CO2 fluxes. So remember, biomet models that have energy balance, coupled water and carbon, match the data. The models that don't do this. Hence, we get that. I think right now, again, we're at another pioneering stage. I'm really excited to see all this advances with LiDAR. I think the LiDAR community is where the FluxNet community was back in '95 when we had the Little Wheel workshop. So I encourage the LiDAR community to have another ski trip workshop and really come together. There's a lot of power to pull together 3D data. We need it, first of all, to come up with better radiative transfer models. I'd like to see the next RAMI exercise be done with real canopies, and many of us are trying to collect data to reach out to the RAMI community to do that. We also need 3D models, at least in the shapes of the crowns and their distribution, to run models like Ed and Maestro. There's a lot of promise from Disney's group and others that we can actually produce ground biomass, essentially. Now, why is this important? Talks earlier talked about satellites only seeing top of the atmosphere remote sensing. So in reality, remote sensing only produces GPP. Anytime you get NPP out of remote sensing, it's fantasy. And it's based on some assumptions of some models. I feel the next generation to get better NPP will be based on models that are based on carbon fluxes, based on stand biomass. So I think there's a lot of promise and potential to try to get something. I mean, I'm not an expert in remote sensing, but so I'm a little naive to say let's have a satellite. I was at a NASA review a few years ago when they were thinking of it. And I do know ISAT exists, and my colleagues like Josh Fisher have used ISAT to come up with global maps of tree height. So it's possible, essentially. And it's not good enough just to have LiDAR data. I think we have to use it to ask scientific questions. And I really take my hat off to Matt Disney and his group trying to think about, let's address some basic questions like scaling of Enquist. Because he's right, there's only a few thousand trees that have been sampled historically. And now we're not sampling, we're measuring the population. And that's a big difference. And so sampling errors that we deal with, errors in allometry that we deal with, are just going to poof away. We're measuring the population. And so then finally, I think we have to maybe establish a LiDAR net system to kind of share and exchange data among everybody. I was also happy to see Lena Mercado and Ms. Veloska talk about diffuse light. Again, a lot of these models come back from Monteith, and they assume constant light use efficiency. But with our radiative transfer models, we found that the slopes of those light response curves will change with leaf nitrogen and leaf area index. So first of all, those slopes are very dependent. But also remember, we're working with complex systems, and an attribute of complex system is scale emergent properties. And one of the top examples of scale emergent properties is this response of diffuse light on carbon fluxes. It's actually much steeper under diffuse light than under clear skies. This is rarely put in the models, essentially. And again, it's this nonlinearity effect that really causes this. So I'll finally end up here, because I really want to try and catch an early train. So recommendations to the agencies. Again, I might be naive, but I'd like to hope for the future we can come up with a global LiDAR satellite for structure, height, biomass disturbance. I think that'd be really cool. I think we need to revisit and update maybe the global pumping maps of Chen. A lot of promise with fluorescence. We saw some talks on that, and I've been associated with Joe Barry and Christian Frankenberg on some new proposals, so I'm learning from them that it's pretty cool. And I think I stressed already that satellites don't infer NPP, they only infer GPP. So we need better ways to convert GPP to NPP, and that takes soil maps and stand inventory maps to get better estimates of the So, can we stop? Just have a summary. Comments, questions?
Thanks, Dennis. So I want to second your call for better radiative transfer models in the vegetation models. But I want to add to that as well that there's another advantage of doing that is in having those better radiative transfer models, we learn to interpret the remote sensing signal more clearly as well.
Absolutely. And I also want to say, it doesn't have to be so daunting. There's two reasons. Several years ago, the soil community talked peer sellers into putting a 6, 8, 15 layer soil model into the computers. And so we can do that now for, I think, canopies because the powers are important. But also remember, we can actually create very simple engineering models based on these PILT types exercises. And then maybe just have simple lookup tables. And so I don't think you have to just run through the things all the time, because given certain canopy geometries, you know, knowing what the sun transfers are and the sky transfers, I think we could actually have some intermediate kinds that are based on the best physics. So, thanks. Appreciate your comment.
halfway through the talk, I was going to stick up my hand and say that satellites don't measure GPP, but then by your summary, you switched it to satellites infer GPP. I think that difference is actually important.
It is. No, I always stress infer, and I sorry I even mentioned measure before. And that's the whole point, and that's why I think flux networks are so important. As ground truth and base stations, they measure direct fluxes. The only problem is they don't do it at the whole scale. But on the other hand, they do see the footprint of this type of room and the components. And they do help us better understand upscale.
Any other comments or questions?
And again, I want to thank the organizers. This has been a great meeting. I've stayed awake most of the time, except for a little jet lag. A couple of times I slept, but it's been very inspirational, lots of fun, and have lots of ideas to talk to my students about. So, merci.
Okay, very good. Thank you. So we are going to the next session. 6, 7.